Our universe continues to grow, making it challenging to establish limits and determine its size. We are able to make use of the James Webb Telescope, now glimpsing into the farthest corners of the universe. Since the James Webb Telescope began, its search, numerous scientists, such as Brian Cox, have made announcements about the actual size and the immenseness of the universe, which is almost unimaginable. Within the fragment of the universe seen by us, there are approximately 2 trillion galaxies. This estimate is derived from research into the local universe. Confident that what we can see is only a small part of what could be a universe that is infinite, but we do not yet know. We are one with the universe, yet we are an essential component of it. The universe in a way knows itself. With the help of the James Webb Telescope, we strike a vast investigation to determine the actual size of our universe. If you're looking to keep up with the latest information about the universe and everything around it, subscribe to our channel, please like this video, and set the alarm to sound. If we were traveling at a speed of 70 miles per hour, it would take us approximately 15 days to complete a round-the-world trip around the equator. It would take approximately 563 years to reach the moon, reach Mars at its closest point, and a staggering 4,400 years to reach Neptune. By themselves, these figures demonstrate the immense dimension of our solar system. Keeping this in mind, we look at Voyager 1, a probe launched in 1977 at a speed of 38,000 miles per hour. It did not leave our solar system until 2012, which equates to 35 years just to escape our solar system. Light, which can go around the Earth 7 times in a single second, appears to be relatively slow in comparison to the vast portion of our solar system. Compared to other solar systems, ours is tiny due to the immense size of the Milky Way galaxy. The number of stars in this galaxy is about 300 billion. And each of these stars probably has its own planetary systems. Our nearest star, Alpha Centauri, is 4.3 light-years away, implying that if we could move at the speed of light, it would require us to travel for 4.3 years to reach it. Consider how much time traveling would take to Alpha Centauri, the next star system. Even if something moved at the same velocity as the Voyager probe, that is 38,000 miles per hour, it would take a staggering 70,000 years to reach Alpha Centauri. This shows us the immensity of the distances involved in exploring the cosmos. Let us now focus on Vela Rouge, a star located 640 light-years away. If we take into consideration the radiosphere, this represents the distance our radio transmissions have covered. Despite the fact that the signals have significantly deteriorated, they have so far reached about 15,000 star systems. However, this figure is only a fraction compared to how many stars are in the Milky Way. If you look at Vela Rouge in the night sky tonight, you're actually seeing the light that left its surface 640 years ago, about 100 years before Columbus set sail for the New World. This light has traveled all that time and is just now reaching our planet. It is truly amazing to realize that on a cosmic scale, Vela is relatively close. To amaze you even more, we must take into account that our radiosphere, which encompasses all human radio transmissions, is merely a tiny dot in the enormous size of the Milky Way. If we were to reduce the size of our solar system to a quarter, the entire United States, the Milky Way, is comparable to the planet's vassals. Within this vastness, there will be approximately 300 billion star systems and their planets. We're just one of those 300 billion star systems floating in the midst of an unimaginably numerous planets and stars. Beyond more than 1 trillion in our galaxy. Yes, 1 trillion galaxies, an incredibly large number. To understand, imagine the size of a collection of cats. Now suppose there are 1,000 cats, 1,000 distinct groups of cats, each with 1,000 cats. That will give us a total of 1 million cats. But to understand 1 trillion, we must remember that 1 million already exists. That number represents 1 million multiplied by 1 million, which is a staggering number of cats. Our most immediate neighbor galaxy is the Andromeda Galaxy, located 2.5 million light-years away. Andromeda is getting closer to us quickly at an incredible speed. As this galaxy approaches, our night sky will undergo significant modifications. This galaxy includes approximately 1 trillion stars, and when it eventually collides with our own galaxy, the Milky Way, with 300 billion stars, the chances of each star individually colliding from the collision of two galaxies are quite small. As evidenced by the vastness and depth of space, the likelihood of direct interactions between stars within a galaxy is low. Galactic collisions, despite their rarity at the level of individual stars, might even help life between stars and galaxies. Galaxies are not static systems, but are dynamic and always changing. As we move away from our galaxy, we locate our local group of galaxies, followed by the Virgo cluster, which is made up of more than 1,500 galaxies. Virgo, in turn, is part of a larger supercluster referred to as Laniakea, which contains approximately 100,000 galaxies. These 100,000 galaxies each have a few hundred billion stars and planets of their own. This is only a minor component of the larger picture. In the observable universe, there are another 10 million similar superclusters. As we zoom out and observe, we discover an increasing number of mapped galaxies. However, these galaxies that have been mapped are only a minuscule portion of what is actually there and incredible number of hundreds of billions of galaxies that have not yet been fully mapped. In addition, we need to think about the cosmic background radiation, which represents the earliest light that can be detected. The leftover heat from the Big Bang. This radiation is a remnant of the early stages of the universe's existence. The scale of the universe becomes even more unbelievable when we think about the vastness that lies beyond galaxies. We locate well-known regions in space, such as cosmic voids, where matter is scarce compared to the rest of the universe. These cosmic voids span hundreds of millions of light years in diameter and appear as significant expanses of seemingly empty space. However, these cosmic voids have the potential to give rise to future galaxy and structure formation. As we move deeper into the universe, we come across cosmic filaments, enormous threads made of dark matter and gaseous dust that stretch across billions of light years, linking galaxies and galaxy clusters. These cosmic filaments form a cosmic web-like structure that binds the universe together through gravitational interaction. The distribution of matter in the universe is not uniform, but exhibits a cosmic web pattern, where clusters, galaxies, and superclusters are linked together by these cosmic filaments. This creates an intricate tapestry that spans unimaginable distances. These cosmic filaments and superclusters, where galaxies congregate, interact through gravity. The vastness of space offers a vast and abundant stage for the existence of countless celestial objects and phenomena, such as supernova, also known as the sudden death of massive stars, dispersing heavy elements throughout the cosmos and enriching the interstellar medium and planetary systems. Black holes, with their enormous gravity, play a crucial role in galaxies' evolution and have the capacity to release jets of energy that extend great distances into space. In the depths of space, we also find exotic phenomena, such as quasars, which are enormous black holes that feed only occasionally and emit colossal amounts of energy. These quasars can outshine entire galaxies and serve as early lighthouses of the universe, enabling us to investigate the cosmos in its early stages. The question arises, what lies beyond what can be seen in the universe? Numerous additional galaxies exist that are beyond our visual reach, as their light has not had enough time to reach Earth. In addition, due to the continuous expansion of space and the constant motion of galaxies, the light from most of these distant galaxies will never reach us. As a result, these areas may remain inaccessible to us indefinitely. As the universe grows, we can make inferences based on what we know about the laws of physics. These inferences imply that the universe as a whole is at least 250 times as big as the observable universe. In fact, compelling arguments suggest that its size could possibly be even larger, perhaps infinite. In this context, a broader perspective emerges that leads us to take into account the universe's nature and our place within it as individuals on a secluded planet in the vastness of space. Contemplating these possibilities encourages us to consider our existence and our roles in the cosmos. So have you ever wondered how vast our universe is? If so, I hope this video was helpful for you to gain a deeper comprehension of the immensity of the cosmos. I hope you use the space for questions in the comments section. If you liked the video, hit the like button, share it to reach more people, and subscribe to not miss more content like this. Much appreciated for watching the video, and see you in the next one.